the three states of matter: first solid, liquid and gas. But in 12th standard fully describe what is solid and different types of solid. So first we have discussed what is solid. Solid means that substance which constituent particles are strongly bonded with each other. So we first write down the definition. Solid means that substance which constituent particle are closely packed and between the molecules or atom force of attraction is maximum. For example, duster, chalk, so next we just recall the properties of solid. So next, properties of solid. So first properties of solid: shape, size and volume are definite. Means, for example, duster. Between the two molecules, the force of attraction is maximum. So solid substance have fixed shape, fixed size and fixed volume. So next property, compressibility. Compressibility is low. We consider two examples, duster and chalk, and third example, rubber. So duster compressibility is low, but rubber is duster compressibility is low, but comparison with duster, rubber is highly flexible or highly compressible. So next, third property, flexibility of substance is also low. Next, rigidity is high. And last property, good conductor of heat and electricity. This property we already studied in 11th and 12th standard. Next one we have start classification of solid. So solid can be classified first crystalline solid, and next type amorphous solid, so we study crystalline solid. Crystalline solid means size, shape are fixed or definite. But in amorphous solid are not definite. So size, shape are not definite. Crystalline solid are regular arrangement order. So next we draw a diagram. First cation, second anion, cation, anion, cation, anion. Next anion, cation, anion, cation, anion, cation. Again replace cation, anion. So in crystalline solid, regular arrangement means cation and anion are fixedly arranged in long range order, but in amorphous solid are short range order or arrangement is not fixed. Like this. Dark circle is denoted as anion. So next point, crystalline solid is a true solid and amorphous solid is pseudo solid or super cool liquid. It means pseudo solid means changeable solid. For example, cupboard, showcase and glass after some time or after some year is thicker in lower side and thinner in upper side. This means it is a pseudo solid or super cool liquid. Next point, its melting point is very high and fixed. Its melting point fixed. For example, a substance is considered as 120 degrees Celsius melting point. So it is fixed melting point of crystalline solid, but in amorphous solid are not fixed melting point. So melting point are wide range of temperature. For example, 100 to 200 degrees Celsius. Next, melting point are wide range temperature. For example, plastic. Plastic made at 100 degrees Celsius, but plastic solid substance it converted into liquid. So in 100 to 200 temperature, it is wide range temperature. So next important property of this crystalline solid and amorphous solid. Next important topic, important point, classification of solid. Crystalline solid are anisotropic. In nature, but amorphous solid are isotropic in nature. Anisotropic means, for example, in structure of atom, middle is nucleus. So second atom like this regular arrangement for long range order, but in cation is surrounded atom, but anion is this direction shows that 3 types of anion, but in this direction shows 2 cation and 1 anion, means different physical properties in different direction. But in amorphous solid shows properties isotropic in nature. Isotropic means same physical properties in different direction or any direction. For example, regular arrangement in amorphous solid are short range order, means this arrangement is not fixed. So this, due to this reason, same physical properties in different type, means amorphous solid are isotropic in nature. So crystalline solid example, NaCl, KCl, and amorphous solid example, rubber, plastic. So crystalline solid, Na plus and Cl minus. Between this oppositely charged ion are electrostatic force of attraction, means it form ionic bond. This force of attraction are responsible for ionic bond, covalent bond, hydrogen bond and van der Waals forces. But in amorphous solid, their arrangement are not fixed. So example, rubber, plastic. So it is also called as pseudo solid. So next we have discussed crystalline solid are main important terms. First, isomorphous, and second, polymorphous. Isomorphous, iso means same and morphous means form. Poly means many and morphous means form. So we just say that isomorphous means same form and polymorphous means many form. So isomorphous means two or more crystal are shows same structure. So isomorphous, two or more substance shows same structure is known as isomorphous. In polymorphous, one substance shows different form is known as polymorphous. For example, isomorphous means sodium fluoride and magnesium oxide. Same atomic ratio, means sodium is 1, magnesium is 1. So fluoride is also 1 and oxygen is also. So atomic ratio for these two crystals are 1:1. So same atomic ratio, same physical properties and same structure. So this is also known as isomorphous. But polymorphous, it is also called as allotropic. So carbon show different types of allotropic, means graphite, diamond, and next fullerene. Another example, sulfur. Sulfur is rhombic and monoclinic and monoclinic. So in crystalline solid can be divided isomorphous or polymorphous. It is also known as isomorphic form and it is also known as polymorphic form. Means same for a many form. So example, sodium fluoride and magnesium oxide, atomic ratio 1:1. Next example, sodium nitrate and calcium carbonate. So atomic ratio for this example 1:1. S2 1 S2 3 means sodium and calcium ratio is 1, nitrogen and carbon ratio is 1 and oxygen is 3. So ratio of this example 1:1:3. But exceptional case is sodium chloride and KCl. Physical properties are same atomic ratio, but crystal structure is not same. Crystal structure is not same. So NaCl and KCl are not isomorphous compound. Exceptional cases, NaCl and KCl are not isomorphous compound. So next point we have discussed also classification of solid. Classification of solid means types of solid. So types of solid. Solid can be again classified as 4 different types. First ionic solid, second covalent solid, third molecular solid and fourth metallic solid. Ionic solid we already know that means constituent particle between ionic solid ions. Ions means cation and anion. For example, Na plus and Cl minus. Na plus cation and Cl minus anion. So between oppositely charged ion to form ionic solid. Next, constituent particle in covalent solid means non-metal atom. So now between two non-metal atoms are formed covalent solid. Next, molecular solid means atoms or molecules present in molecular solid. Next, metallic solid means metal. So next, force of attraction in types of form. So ionic solid force of attraction are formed electrostatic force of attraction. Electrostatic means to form between oppositely charged ion are formed ionic bonding. So in covalent solid force of attraction are covalent bonding. In molecular solid are very weak bonding. Weak bonding means dipole-dipole interaction or van der Waals force. And in metallic solid are formed metallic bond. For example, in any metal, for example iron, aluminium, are arranged in fixed manner and between this delocalized electron is known as sea of electron. So metallic solid form metallic bond. So metallic bond means attraction between metal and sea of delocalized electron. Next, third property, hardness. Ionic solid are very hard. Covalent solid are very hard. Molecular solid are soft. And in metallic solid, hardness property are variation from soft to hard. Next property, melting point. Melting point of ionic solid are high. ionic solid, covalent solid are very high. For example, diamond metallic point is 3300 degrees Celsius. Molecular solid melting point is low, and metallic solid are wide range of means high. Next, conductivity. Conductivity in ionic solid are poor, but exceptional cases in molten state means NaCl dissolve in water, so it shows Na plus and Cl minus, means it shows conductivity. Next, conductivity in covalent solid are poor, but exception cases diamond and graphite. In molecular solid, conductivity is poor, and in metallic solid, conductivity it shows very good conductor. For example, iron. So iron Fe2 plus, it acquire 2 plus charge, means it remove 2 electron from isolated atom. For example, these ions are arranged in fixed manner but removing 2 electrons. For example, 1, 2, 3, 4, 5. 5 ferrous ion means 5 to the 10 electron are floats around the iron atom or iron cation. So it shows good conductor of heat and electricity. For example, last point we give example, so we clear that. So ionic example, NaCl, KCl, ZnS means between two oppositely charged ion. Covalent solid means same atom or non-metal. For example, carbon to carbon bond means covalent bonding, or silica. Silica means sand. Next, molecular solid. Molecular solid means, for example, ice, benzoic acid. So ice, between ice means solid compound, are weak bonding means van der Waals force. And last, metallic solid. Example, sodium, silver, aluminium are present in metallic solid. So types of solid can be clear on this chart. So next point, one point we can give. Next point, glass. Glass means optically transparent material produced by fusing together silicon oxide, sodium oxide, boron oxide, and trace amount of transition metal oxide is added to impart color. It is also known as glass. So glass can be manufactured in different types of glass. So first, Pyrex glass. Pyrex glass is used in laboratory apparatus and kitchen vessels. So Pyrex glass in composition 60 to 80% silicon oxide, 10 to 25% boron oxide, remaining amount is aluminium oxide. Next type of glass is soda lime glass. Soda lime glass is 75% silicon oxide plus 15% of sodium oxide and 10% is copper oxide. Next, red glass. Red glass can be prepared trace amount of gold and copper. Next, green glass. Green glass is iron oxide and copper oxide. Yellow glass is uranium oxide and blue glass is cobalt oxide or copper oxide.